Alright, so recently I started learning some sounds or some sound physics in my physics class, and so I figured I'd make a quick little program because some of the transformations or translations or whatever they're called are going to be done a lot of times, and so I figured I might as well make a little simple program to make it a lot easier. And so I won't go over all the math, but pretty much this is what the program is, and so you're translating decibels into watts over square meter, and so the quick programming speak that I can explain is you have the menu, which is asking for the function that you're trying to accomplish, not are you having fun or do you want to have fun, and it's asking if you're trying to translate watts into decibels or decibels into watts, or if it's sound intensity over a distance, and so you do that calculation, and so store a variable, and I'll show another program that I also wrote, and I think it's pretty interesting. But you store a variable as a number, or you store a value as a variable, and then you can call on that variable again instead of having to rewrite the number every time, because I do repeat that I a couple of times later on. So you're going to prompt for the sound that you're originally given, then you're going to display, and so instead of having to prompt, then do the actual calculation, and then store the calculation to a variable, and then display the variable, you can just display the outcome, or display the variable and take out the middleman or the middle step, or just display the outcome, I guess. So I rewrite it here and I store it to list 3 at element 1 plus the dimension of list 3. Calculator turned off. And the reason I do that is so that I can have a list of list 3 of all the programs that I've run, or of all the outcomes of the programs that I've run. So for example, if you then hit clear, you won't really have your answer unless you use the recall button, which I guess would work, but if you have multiple outputs, it might not work exactly. So this way you can just check your list 3 and be like, okay, I know the last program that I ran was this, and I know the outcome should be this, and if you want to, you can get really fancy and actually store this as the outcome of or output of the program as a variable. So for in some programs I stored a z, and so you'd have it really written 3 times. You'd have it displayed, you'd have it stored to list 3 at element 1 plus the dimension of list 3, which basically stores it to the end of the list, and it creates a new element. And then you also store it to variable z, and so if you want to know what the number is because you forgot it, you can check the list, or you can use the variable, and if you want to rewrite the or use the answer in another equation, you can just call on the variable z. Anyway, and because it's an if, it was supposed to be an if then, and I haven't tested this, so actually that's not supposed to be in there. Yeah, I don't have an end in here too. Okay, good, because there's not supposed to be one there. I used to have it as an if x is equal to 1, and I'll get into that in my other program. Same thing for here, basically the same thing, but I'm doing the opposite calculation. The numbers, the calculations, I'm not really talking about, not really important, because that's not the vital thing here. If you want to check my math, then you can do so, or use the actual programs that I have written, or the equations that I've written out, but I would not recommend that. And then this third one is, again, more fancy math stuff, but just prompting, and then displaying, and then storing it at the dimension. And so I'm probably going to add a couple of other functions, because there might be other things that I might need or reuse, because the important thing about a program is is it something you're only going to do once, or are you going to do it multiple times? And if you're going to do it multiple times, is the input and output roughly the same? Because if you're doing a different problem each time, like I get that on physics tests, it's like, okay, do you know the math well enough to solve for this given variable? It's like, well, yes, I do. And so if you have a program for that, fantastic. But if you don't, then you're kind of screwed, because you don't. You're relying on your calculator to know the things that you don't know, which is why you also really need to understand the math behind it, so you can make sure that your calculator is correct, and then also not fail the test when you're thrown a question that you didn't prepare for. So it's something that has to be monotonous to a degree, and repeatable, and also programmable. But that's basically theory of programming. Okay, set. So this is a program that I kind of want to change to the name book, but it's a long list of variables. And so if I want to run it, I have to set x at a given variable. I have the first line is x is equal to 1. Second one down here, if I can scroll, is if x is equal to 2. And then the third one is if x is equal to 3. And so they each correspond to different functions. For x is equal to 1, it's actually to set all the variables. And so this is Avogadro's constant, this is Boltzmann constant, this is the speed of light, this is the amount of seconds in a day, this is E, don't know what that is, I forget. That's gravity, that's number of seconds in an hour, that should be the intensity, sound intensity thing. Anyway, so I've set them all to things that are relevant to what the variable is, and so if I want to reset some of if I want to use these constants now, I can actually use them instead of having to look them up each time. I know that they're corresponding to a specific variable, and then if I want to reset this because I ran a program that uses variables, like if I set g to a different number and then I go and try and use the speed of gravity, then it's not going to give me the answer that I want because g is going to be like 5 or something. It's not going to be 9.8 or 9.81, and so I can reset it. And then the importance of the second one is to basically read the book, and so I don't really have a good metaphor for it, but pretty much I explain what all of the variables are. So it's Avogadro. It's like, okay, well, I'm not going to take the entire time and space to write out exactly every single word, like Avogadro's constant, and then explain what it is, because I kind of know what Avogadro's is, because I took chemistry, thankfully. So Avogadro's, Boltzmann, light, seconds in a day, E, the LF of water, so latent freezing or latent fusion of water. So that was for last chapter in my physics class. We were going over water and how much energy it took to melt ice into water, or something like that, or water into ice. The same difference. So I explain what they are, and if there's no value attributed to them, I just have 0. So if I want to attribute a value to that variable, I can. And that way I don't call on a variable thinking that it has a value that it doesn't. So if I'm ever confused, I can check this, or if someone's using my calculator, they can check it. And then if I want to clear all of the values, then I can just run the third one, which sets them all to 0. And it's not a very complex program. It's basically just 3 if-thens with a lot of commands written to it. And then another thing that was really difficult about this was spacing all the numbers out, because if they're less than, I think it's 11 or 13 or something like that, I think it's 13. If they're less than 13, they have a slight overlap, and so it looks kind of triggering because it's slightly overlapped and you can't really exactly see it. But I didn't have too much of a problem figuring that out. Okay, here's the thing I was talking about a little bit ago with the list 3, dimension of list 3 stores z. So it's basically set the last output of the last equation or last program that you ran as the variable z. Basically, if you're on the ball, pretty much you can just use second answer, which is second, and then there's a negative sign, which basically just takes the last output of a command that you, or last output of an equation that you ran, or doesn't even have to be a program. So if you do 2 times 6, the output will be 12. If you do 2 times the answer, it'll be 2 times 12 instead of having to rewrite 12. And so if you have like a really complex decimal, instead of having to copy it down one by one, and you also don't want to round, because I've had that problem in my calculus class where people round and think they'll be fine, and then the computer says that they're wrong, and it's like, wait, how am I wrong? I just rounded a little bit. It's like, no, you have to use the exact decimal. So that's, that could be relevant if it doesn't matter to you, or it's not relevant to your class. Okay, whatever. I might update you guys with a little bit of the sound equations if I find any more or make any more. Like I said, it's based a lot on what your information that you have is, because if you understand what the math is, great. If you understand what the math is and know how to program it if it is programmable, like, more power to you, and then you can actually use that program. But the downside is that it is a program, meaning it can't really change, which is why my kinematics program was so big, because it was like, there's so many different situations that can be thrown your way, and you have to account for all of them. So sometimes it might just be easier to learn the math than to actually figure out the math and then write a program for it. Anyway, that's all. Hope you guys have good luck in programming and don't die.